Welcome to this online revision session for AQA FP3, in which we're going to look at the January 2011 question 3 on the topic of polar coordinates. As you can see, we're given the polar equation r times 1 plus cos theta is equal to 2. First part is we've got to transform that into the Cartesian equation. Then in part B, we're given that this particular curve intersects with a straight line, and we have to find the distance between the 2 points P and Q of intersection. Okay, well, on to the first part, finding the Cartesian equation. We know that x is equal to r cos theta and y is equal to r sin theta. And the other key fact that we need is the fact that r squared is equal to x squared plus y squared. So if we start by multiplying out the brackets, we get r plus r cos theta equals 2. And then using x equals r cos theta, we can then substitute and end up with r plus x equals 2, and then r will be equal to 2 minus x, and now we need to replace the r, so remembering the fact that r squared equals x squared plus y squared, then we can square this and then replace r squared with x squared plus y squared and multiply out these brackets to give us x squared minus 4x plus 4, and so we can see now the x squareds will cancel on either side, and we get y squared equals 4 minus 4x, which is in the form of the answer that we require as y squared as some function of x. Well, we get 5 marks for doing this part. So for stating or initially multiplying out the brackets, we'll get a mark. And then for using the substitution x equals r cos theta, we'll get a mark. Then ending up with r equals 2 minus x as an answer, we'll get 1 mark. And then for squaring it and using that substitution for r squared, there'll be a mark. And then finally for tidying it up to the form that we require, or anything else that's equivalent to 4 minus 4x, we will get the final 5th mark. Moving into part B then, remembering that we've got the fact that y squared equals 4 minus 4x. First thing we need to do is to find these points of intersection. Now they can either be in polar form or in Cartesian form. Knowing we've got this polar equation here, remembering that sec is 1 over cos, if we rearrange that equation, we can get the fact that r cos theta is equal to 3/4. But of course we know that r cos theta is equivalent to x. So this is telling us the x value. So it looks as though the Cartesian form is probably the easier way to find the coordinates. So x is 3/4, so we can now substitute that value into the equation of the curve. So we've now got the fact that y squared will be equal to 4 minus 3/4 times 4, which of course gives us 1. So if we square root both sides, that tells us that y is either plus or minus 1. So this is giving us our two coordinates as being 3/4 1 for one of them, and the other one will be 3/4 minus 1. And now it becomes fairly obvious what the distance PQ is going to be equal to, because the x values are both the same, and the distance between the y values, where one is 1 and the other one's minus 1, is 2. So PQ is going to be equal to 2. So again, a method mark for obtaining the fact that x is 3/4, and an accuracy mark as well. And then the fact that you then manage to get y as plus or minus 1 on the way to finding these two coordinates, and then finally stating that the distance between the 2 points PQ is 2 is going to give you 1 mark. Hopefully you found that solution helpful. For more assistance with your maths revision, please go to the Further Maths Support Programme website.